Projectile motion is a form of motion in which an object or particle called a projectile is thrown near the Earth's surface, and it moves along a curved path under the action of gravity only. The only force of significance that acts on the object is gravity, which acts downward to cause a downward acceleration.
Calculating projectile motion can be used for things that are launched or thrown. Using the calculations, you can use projectile motion to determine what height an object is at a certain time, what angle the object was initially launched, what distance it can cover, and what height it can reach. In this video I will be covering all of these topics and teach basic scrubs like you how to projectile like a pro. Velocity is the speed of something in a given direction. For example, 400 meters per second east. Gravity is the force that attracts a body toward the center of the Earth or toward any other physical body having mass. The unit of gravity of the Earth is 9.8 meters per second. Angle is how high something is launched. The angle in a projectile has a minimum of 0 degrees and a max angle of 45 degrees. This is because we aren't launching anything backwards, in that case using the whole 180-degree range instead of 0 to 45. Basic LV-L1 equations. Velocity equals distance divided by time. This is because the height of the velocity of the launch is, the longer the distance it reaches and the shorter the time it takes to travel. In other words, velocity inversely proportional to time and directly proportional to distance. Distance equals velocity multiplied by time. The longer something travels, the more distance it covers, so you multiply. Time equals distance divided by velocity. Again, time is inversely proportional to velocity. The shorter it takes to reach an area, the faster the object must be going. You can use cheat sheet Illuminati triangle to help you memorize. Cover finger on the equation you want. We learned how to calculate objects in a horizontal motion, now it is time to use vertical forces. Gravity is that vertical force. Any object that is moving and being acted upon only the force of gravity is said to be in a state of free fall. Such an object will experience a downward acceleration of 9.8 meters per second squared. The motion of an object in free fall can be described by 4 kinematic equations. The kinematic equations that describe any object's motion are: displacement equals initial velocity multiplied by time, plus 1/2 times acceleration, which is 9.8 meters per second squared, multiplied by time squared. You multiply the initial velocity by time to find the horizontal displacement like we did earlier. You add 1/2 times acceleration because if you were accelerating at 10 meters per second squared for 1 second, in that 1 second, you started out going 0 meters per second and you ended up going 10 meters per second. Your average speed would be right in between, at 5 meters per second. If your average speed is 5 meters per second for 1 second, your distance is 5 meters, and there's your half. This second equation is used to find final velocity without a given time. Final velocity squared equals initial velocity squared plus 2 times acceleration times the displacement. You square the initial velocity to adjust towards 2 times the acceleration and the displacement. Square rooting these figures finds the value of the final velocity. This third equation is used for final velocity with time. If you know how long an object is accelerating, add that force with the given initial force, you will find the total for the final velocity. The fourth equation. Displacement is equals to the average velocities of the initial and the final multiplied by the time. The average velocity gives the constant speed it is going, multiplying it by time gives the total displacement. The curved path along which the projectile travels is what is known as trajectory. Projectile motion formula, trajectory formula, is given by the formula where Vx is the velocity along x-axis, Vxo is the initial velocity along x-axis, Vy is the velocity along y-axis, Vyo is the initial velocity along y-axis. G is the acceleration due to gravity and t is the time taken. Equations related to trajectory motion, projectile motion, are given by this, where Veo is the initial velocity, sin is the component along y-axis, cos is the component along x-axis. Remember basic trig? Well, you use it again for finding the angles. You can see the diagram and what the given ratios can be used to help you find the vertical or horizontal units needed if asked. Let's do a few basic trig to refresh how this goes. Did you do well? Now let's go on to the real thing. This time we'll integrate trig to find the missing horizontal or vertical velocities and missing angles. We'll also review from the past lesson that kinematics equations still applies. The only thing that is different here is the trig.
You should draw a diagram like this. You should base your diagram on the equations I have given earlier. 550 meters represents the displacement in the kinematic diagram. Acceleration is 9.8 meters per second. Since initial velocity is not given, nor is final velocity and time, you would have to find those. By drawing a triangle, insert the given velocity of 76 meters per second as the hypotenuse. Since this velocity was at an angle of 25 degrees, insert the angle. Now you need to find the initial velocity along the y-axis and the initial velocity on the x-axis. You use sin and cos because you were in it ally given the hypotenuse and angle. To find initial velocity along y-axis you use 76 times sin 25. This is because we are finding the triangle ratio of the opposite side which gives velocity along the y-axis. Now that you found the y-axis velocity, find the x1. Multiply hypotenuse of 75 with cos 25 to find the adjacent which we now know. To find the answer for the first part, use the second kinematic equations with the values. This solves the final velocity on the y-axis which tells us how long it fell. Then use the third kinematic equation to solve for time. We have initial and final y velocity and acceleration. Put this into the equation and now you solved the time. For the second part, it is asking for the angle at the final velocity. We know already the final velocity of y which is 108.7 meters per second. We also know the velocity of x which is 68.88 meters per second. Draw an inverted triangle because the problem wants the angle below the horizontal. Use the given values and the trig formulas to find the angle. Here we use inverse tangent of 108.7 over 68.88 to find the angle. You should get 58 degrees below the horizontal. Now we find the final impact velocity. Use the Pythagorean theorem to find the hypotenuse. Finding the hypotenuse of this triangle finds the impact velocity because it uses the ratio of final velocity y at the end with constant velocity x. You should get 130 meters per second.